Alright, so in mutual induction, M21 is equal to, we have seen that M21 is equal to minus E2 divided by di by dt. Okay. And suppose you consider di by dt is equal to 1 ampere per second. Okay. So then what will be the equation? This is equal to 1 ampere per second. So M21 is equal to minus E2. So then one thing it is very clear that we can define the mutual inductance. So look at this, mutual inductance of a coil 2 with respect to 1 is equal to the opposing EMF on the coil 2, which is equal to opposing EMF of the coil 2, when the current di1 divided by dt, that is di1 divided by dt is equal to 1 ampere per second. Or the opposing, it is mutual inductance, we can define it as it is the opposing EMF induced in the coil 2 when the rate of change of coil 1 is equal to 1 ampere per second. Alright, so this is how we can define this one. And also you just note that I have told you to work on the other equation, I mean the second case. If the secondary coil is like the current is passing through the secondary coil and the induced EMF is producing on the primary coil, then what will happen? So M12 is equal to N51, and I think you have got the same result, N51 divided by N512 divided by I2, and we can write it like this. Okay, so M12 is equal to minus E divided by di2 divided by dt. I can write in this sense also. Okay, alright. So then I can write it as M, like from the two equations, that is from the beginning equation, this one, and that equation, I can simply write it as if the currents and the EMFs are producing, and if the currents are same, so then M12 is nothing but M21. It is very clear from the equation, M12 is equal to M21, which is equal to M. So the mutual inductance of a pair of coils is equal like here M12 and M21. Okay, so suppose there are two coils, so the mutual inductance between them are equal with respect to each other, and like this mutual inductance actually it depends on size, shape, number of turns, and the relative orientation. Okay, always remember size, shape, number of turns, and then relative orientation. Okay, so this is actually important. Like it's not a very important point, but sometimes you have to keep in your mind this. Okay, so then because we have to discuss about in a solenoid, what is the mutual inductance of a solenoid with respect to another one. So then next we are going to talk about the unit of mutual inductance. And what is the unit of mutual inductance? Suppose you consider, then first we take that equation. I1 is equal to 1 ampere, N2521 is equal to 1 Weber per turns, then M21 mutual inductance of second coil with respect to 1 is equal to 1 Henry. Okay, you can use the other equation as well, but I just want to define it in that way as well. Okay, and then okay, so okay, from this it is very clear that so what is 1 Henry? The mutual inductance of second coil with respect to first coil is said to be 1 Henry when the current passing through that primary coil is equal to 1 ampere and the flux linked with the circuit is equal to 1 Weber turns. And similar way we can define by using the other equation as well. What is the equation? M21 is equal to minus E2 divided by di1 divided by dt. Okay, you can use that equation. Okay, what is that? di1 divided by dt is equal to 1 ampere per second and E2 is equal to minus 1 volt. Then what is M21, which is equal to 1 Henry? Okay, so it is very clear that when the mutual inductance of second coil with respect to first coil is said to be 1 Henry when the current passing through or current per time or rate of change of current is equal to 1 ampere second on the primary coil, and also the opposing EMF 1 volt is acting on that, and opposing EMF of 1 volt is producing on the secondary coil. Okay, so this is how we can define. So you think about the equation only, apply the values and then make it 1, then that define in that way. Okay, don't forget one thing. Why this negative sign? It's opposing EMF. opposing EMF, because without this word you will not get the mark. Okay, so that's it. And next we will talk about the mutual inductance of a solenoid. Alright, thank you.